Good morning, good evening, good afternoon, boys and girls. It's time for another lesson. Today we're going to study IPv6 routing, static routes, and OSPF version 3. So let's go, boys and girls. What do we have for this lesson? So, this is the agenda. We have IPv6 basics and addressing, static IPv6 routing, syntax examples, verification, OSPF version 3, concepts, configuration, verification. Once again, we are doing validation. Then we have topology diagrams, tables, and lab exercises, best practices, and troubleshooting checklists. That's what we have for today's lesson. So let's go with the agenda. And the first thing we are going to learn is what is IPv6? What is IPv6? So now let's go with the definitions. So is a next generation internet protocol with 128-bit addressing. It solves IPv4 address exhaustion and improve routing and scalability. Built-in features, larger addresses, space, simplified header, multicast improvement. So that's what we have. So it's a next generation internet protocol with 128 bits addressing. It solves IPv4 address exhaustion and improves routing scalability. Built-in features like larger address space, simplified header, and multicast improvement. That's IPv6. Let's continue moving forward. And now we have an example of IPv6 address and IPv6 structure. We have hexadecimal values here. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have a total of 8 groups of 4 hexadecimal values or hex digits, and this will sum up to 128 bits in total. Let's continue moving on, and we have the IPv6 address types. And when we talk about them, we're talking about global unicast, link local, unique local, multicast, and anycast. Those are basically. Now, broadcast doesn't exist in IPv6. So just for you to be aware of that, we only have global unicast, link local, unicast, unique local, multicast, and anycast, right? So let's go with the definitions and the description. Global unicast is a public routable IPv6 address, IPv6 addresses. Um, link local is used on a single link, not routable. Unique local, ULA, is private addressing similar to RFC 1918. One-to-many delivery, that is multicast. And finally, we have anycast, assigned to multiple interfaces nearest response. So this is an example of a global. We have the global unicast address, and this is the first example. Then we have a link local um, IPv6 address, and that's the other example. That is FE80 colon /10. Then we have the unique local, and that will be FC00 /7. And finally, we see the multicast there. One-to-many delivery, FF00 /8. And anycast is assigned to multiple interfaces nearest response. It's the same unicast address assignment. So you guys saw the unicast. So it will be pretty much the same one as this one right there, the unicast. We have the global. This is the unique local. It is unique at address. So it is actually, let me erase that one. It is actually not this one. It will be that one over there, the unicast, the global unicast, according to what it says. So that's pretty much the address, IPv6 address types. Let's clear the board and let's continue moving on. IPv6 subnetting practical. So /64 is the standard subnet size for most LANs. 64-bit interface identifier. The common site allocation is /48 per site, /56 per subnet in zone ISPs, Internet Service Providers. Finally, we have here the prefix notation example, and we have 2001 column, DB8 column, 10 column, and /64. That will be an example of an IPv6 address, which is the standard subnet size for most LANs, within this format bit interface identifier. Okay, let's clear this and let's continue moving on. Okay, here, once again, we have the global unicast example. This is located and basically assigned to a host on a LAN. Then we have the local link, and this is FE80 column 1. This is how to configure on interfaces. We have the unique local address, which is a private addressing. In this one, the example is FD00 column 10 column 1. And finally, multicast, which is FF02 column 1. All nodes on a specific link. That's basically it. Let's continue moving on. Okay, this is an overview of routing in IPv6. IPv6 routing principles are similar to IPv4, forwarding based on prefixes, static routes for smaller, simpler topologies or control. It's basically static routes are used in a small or simple topologies. Um, that is the administration that we are doing with the static routes. Finally, this is the last piece of the puzzle. The last piece of the puzzle is dynamic routing, IP OSPF version 3, BGP, EIGRP for IPv6 for scalable environments. Now, IPv6 route syntax. What do we have here, guys, boys and girls? Okay, this is IPv6 route, and then the prefix, the next hop IP address, and the distance. That is the basic Cisco command in the iOS. Then for interface base, we have IPv6 route, then the prefix, and then the exit interface. So we can configure on next hop IP address or interface, exit interface. What else do we have here? The default route example. This is the first example, and this is the second example. IPv6 route. This is just an example. It's not actually the first or the second. It's just the steps to create the default route example. So the first step, we configure IPv6 route :/0, and then we added that IP address 2001 DB8 :1 :2. And the way that we do this is basically just writing in a single sentence this. So we will have something like this. We will have IPv6 routes, and then we will have column. Give me just a break. I got it. Column 0, and then we have 2001 DB8 :1 :2, and that's an example in one single line how to configure a default route in IPv6. Let's continue moving on. Let's clear the board. Let's move on. Now, this is an example to configure a static route in IPv4, in IPv6, I'm sorry, in IPv6, and this is basically the example. We have within the router, we have the router 1 and router 2. We configure this interface gigabit 00. We have the IP address, IPv6 address. We have the interface gigabit 01. We configure the IPv6 address, the route. This is actually the specific default, the specific route for a next hop IP address after the prefix. And we're doing exactly the same for gigabit 00. We configure the IPv6 address here. Then we have an IPv6. Then we have in gigabit 01 another IPv6. So just writing so you guys keep this in mind. This is the first one. This is the second IPv6. And then we have a route, a default route per se. But this one is um configured for the next hop IP address. Remember, we can configure a default route um with the 0 option with the next hop IP address, and do you guys remember the last one? With the interface. So just remember that interface. With that interface, we can also configure that. So let's just return to the previous slide so you can remember those. We have the option to configure with the basic command and the next hop IP address, with the exit interface, and with the 0 option, and the IPv6 address. Summarize. This is actually like removing the zeros from the IPv6 address. All those blocks of zeros, we can translate those into a column, and that's basically what we're doing there. Let's continue moving on for the next slide. And this is some validation commands that we have. Show IPv6 route to view the routing table and active routers. We have pin IPv6 address and trace route IPv6 address for path testing. And finally, show IPv6 interface brief to validate addressing and link status, to verify addressing and link status. That's basically it. Let's clear the board and let's move on. Next thing, imagine you have a router over here, another router over here, and another router over here. These are already labeled. So we have router 3. Let me just clear that one because I don't want to confuse you. Usually the boxes are for switches, so we have the circle ones for the routers. So we have router 1 over here, router 2 over there, and then we have router 3. And basically we can just go to ChatGPT, configure the IP addresses using Cisco Packet Tracer, and ask for, please create a Cisco Packet Tracer lab so we can add this IPv6 address for both router 1 and router 2. And then this other IPv6 address for both router 2 and router 3. Now, ChatGPT or any artificial intelligence capable of will give you the step-by-step on how to configure this in Cisco Packet Tracer. So it just shouldn't be a big deal. You can actually do it by yourself. Just pop up 3 routers, connect the straight through cable between them. Actually, it will be a crossover. It will be because they are the same devices. So it will be a crossover cable. So you will be connecting a crossover between all those routers, crossover cables, turning the interfaces on and adding IPv6 with the IPv6 specific command. That's basically the lab. It shouldn't be that difficult. Once you have IPv6 configuring this interface, and this other one, and this other one, we should be all done. So let's say this one is gig. Let me see. Let me think. Let me just clear the drawing for a moment with the board, with the eraser. So let's say this is gigabit 00, and this other one is gigabit 00, and this other one is gigabit 01, and this other one right here is gigabit 01. So what you're doing is you're configuring the same IP address for a gigabit 00 and 00, those interfaces for router 1 and router 2. And then the other IPv6 address, you're configuring that one in gigabit 01 and 01 for in order to have communication between those devices. Usually what it changed is like we have a that one and a that two for those addresses. And then we have a that one and we have a that two. And that's basically it. That's the lab. Let's clear the drawings and let's move on. Okay, this is the example that I was telling you about. So you have for router one, the specific IP address. This is actually the one IP address for gigabit 00 and gigabit 01. You have the other IP addresses is that one as well. You have the static default route connecting to a next hop IP address. And then you have the same, exactly the same for router 2. We have the .2 IP address over here for gigabit 00. Gigabit 01, we have the .1 connecting from router 2 to router 3. In this case, gigabit 01 will be, let's see what we have here. It is just another one, but we're pretty much connecting them together. Let me validate. We are configuring static routes to get to the next hop IP addresses. We are configuring just a specific IPv6 address to connect between gigabit 00 in router 3 and gigabit 00 in router 2. And we are configuring the other IP addresses to have fully connection between um, gigabits 01 and 01 router 2 and router 3. Now, notice that they are pretty much in the same network, but we have a 30 over there and we have a 2 over here, but they should be able to connect successfully with no issues or problems. And finally, we have the IPv6 route with the next hop IP address to get to that column 1. This is actually to get to this specific IP address, which is located in router 2. Router 2 has this specific IP address that we are going to use as square, so you can fully understand that is the one we will be directing the traffic. So we are getting for the specific IP address, in this case, we are getting from this IP address. This is like a source IP address. We are getting to that one in router 2 and so on. This one is also default route 10, default route 30. We are trying to get to router 1 via this one and router 2 via this one. So that's pretty much, this one is directed to the specific interface that goes to router 2 per se. And this one is also going to router 2 if you take a look at that one. So it's just a little bit of practice and becoming familiar with the IPv6 format. It might be a little bit confusing at the first stage because you're trying to adapt, but it's pretty much the same routing capabilities and options. Just remember to validate and confirm you are assigning the correct IP address every time you are assigning it, configuring a lab, and that's pretty much everything. That's pretty much everything. Let me clear that and let's move on. The next one is actually about OSPFv3 introduction, and OSPF adapted for IPv6 address family aware, commonly used in IGP for IPv6 routing. It uses core concepts of OSPF version 2, areas, LSAs, DRPTR, or multi-access networks. OSPF version 3 supports IPv6 link local addresses for neighbor adjacency establishments. Okay, so those are the bullet points for that one. We are pretty much done. Let's continue moving on. Next thing we do is that here we have the differences. We have OSPFv3 operates on IPv6 and removes IPv4 header assumptions. LSAs are similar, but OSPFv3 separates routing and address families, and configuration is done on IPv6 router OSPF, IPv6 OSPF per interface. So we have those options. We have that operates IPv6 and removes the IPv4 header. That's the OSPF version 3. The LSAs are similar, but OSPF v3 separates routing and address families. And finally, the last one is that the configuration is done with the IPv6 route OSPF and IPv6 OSPF per interface. That's pretty much. Let's go ahead and clear the board. Let me just clear it and move on. Let's move on. Okay, now let me just annotate here some information with configuration workflow for OSPF v3. We have the following. Let me use the highlighter for this one. Let me choose the green color. We have to enable IPv6 unicast routing. That is the first step. Then we have to configure the IPv6 router OSPF, the process ID, and set a router ID. Then we have to configure each interface IPv6 OSPF, process ID, and then the area ID, and verify the LSDB and validate the routes in the IPv6 RIP. Okay, let me show you guys an examples of this because it is actually easier to understand if we have a clear example. Let's clear the drawing and let's move on. Okay, so this is an example. We are configuring the IPv6 router OSPF1. The router ID is 1.1.1.1. Of course, we are working. Let's just give the example. We are working on router 1 for this one. Then interface, IPv6 address, IPv6 OSPF1 area 0, interface gigabit 01, IPv6 address here once again, and OSPF is IPv6 OSPF area 0. Both are in area 0 for this specific interfaces, and we already configured the IPv6 router OSPF1 and the router ID for that specific router. Remember, you have to do it still in configuration mode, so it will be something like this. It will be something like config, config, and then a number sign. It will be something like that. You will be in configuration mode. And basically, the same configuration will be applied to router 2 and router 3 effectively at some point. So let me clear the board for now and let's move forward. Oh, these are some validation commands. So we have the show IP OSPF. It will show us general OSPF v3 status. We have the show IPv6 OSPF neighbor. So show IPv6 OSPF for general OSPF version 3 status. Show IPv6 OSPF neighbor for the adjacencies created or formed by OSPF version 3, v3. Those are table adjacencies. Show IPv6 route OSPF, the routes learned via OSPF v3, and show IPv6 OSPF database, LSDB, and LSA details. We will be able to see those informations there. Okay, let's continue learning about OSPF v3 a little bit, and this is what we have now. So let me just wait for a moment and let me use the highlighter for this one so you can have a better view. Let me use the green color and the normal backbone. What do we mean with normal backbone? Normal backbone is the default area for the intra-area routing. That's the main connectivity area 0. Then we have the stop. Blocks external type 5 LSAs to reduce routing table size. Thus, most sites that don't need external routes. That is the stop. Area type 4, we're talking about area types. For OSPFv3, it says that it blocks external type 5 LSAs to reduce the routing table size and small sites that don't need external routes. Totally stubby is basically blocks inter-area and external LSAs, more restrictive, and is for very simple remote sites. And finally, NSSA, non-stubby area. It allows limited external routes without full external LSAs when you need external reachability selectively. That's when we use the non-stubby area, NSSA. Then let me just clear the drawing for a moment and return to the green color. Let's skip on the green color. This is a static version OSPFv3 quick comparison. We have the static routes and we have the OSPFv3 and the aspect. For configuration effort, for static routes is low for few routes, and OSPFv3 is higher initial effort. Scalability, poor on large networks, designed for large networks. So that is static routes. This is the characteristic. And then OSPFv3, this is the characteristics. Designed for large networks. Designed for poor, it will be running for all large networks. So for scalability, the best option will be, of course, OSPF version 3. Convergence is manual and slow for static routes, and for OSPFv3, of course, as a routing protocol, it will be faster and automatic. And finally, for control, it complete manual control. And this is static routes. It gives us complete manual control, but for OSPFv3 being a routing protocol, it will be dynamic in its tuning both areas and metrics. That's it. That's a little bit of the comparison that we have so far. Next, verify IPv6 addressing and link local reachability. Being link local with a specific interface, check the routing tables with the show IPv6 route. For OSPFv3, verify neighbor and LSDB with the show IPv6 OSPF neighbor or database command. And finally, use the traceroute IPv6 and do some debugging for deeper issues or troubleshooting issues. And this has to be probably outside business hours, not affecting production in a maintenance window. Those are a little bit of the best recommendations that we have for you guys to follow along. Okay, next. What we have on page 22 is actually a suggested lab. We already talked about building a tree router topology with a static route and a specific IPv6 address, validate the convergence of the routes, introduce an outage. You can do a shutdown for a link. You can even do some debugging commands as well. Use some AI so it can guide you step by step how to perform this. And finally, configure area types and then test route propagation. If we have to do this later on during the bootcamp and it's according to the program, we will do some labs related to this and mainly IPv6. But for now, let's just stick that this is a great idea to practice and get some hand-on experience and configure area types and test the route propagation. That's basically um, a recommendation to create a hands-on lab exercise. Let's clear the board and let's continue learning. Finally, we have a little bit of a summary of the topics that we have gone over today that we have learned so far. And these are basically some of the topics. IPv6 is essential and routing concepts map closely to IPv4, but with new addressing. Static routes are simple. OSPFv3 adds scale and automation for IPv6 environments. Suggested next steps, practical labs, read vendor documents, and OSPFv3 RFCs for deep dive. So it's been a pleasure. Let me just return to the red color for now. So we cover pretty much everything related to the essentials for concepts for IPv6, most of the fundamentals for OSPFv3. We have some recommendations and suggestions on how to create a lab with both IPv6 and OSPFv3. So take care, boys and girls. I will see you at the top of success. It's been a pleasure working with you today, learning about these concepts, learning a bit about OSPFv3, IPv6, all the fundamentals. I'll see you around until next class. Goodbye.